Hi there. Today we're going to be talking about scatter plots. Got a couple examples of what these look like, how to graph them, and then in the next video we're going to show how to find what's called the line of best fit. Alright, this got a little smudged here, but a scatter plot is a graph that relates, a graph of multiple points that relates two sets of data. Alright, hopefully that should be a little bit clear. Once again, a scatter plot is a graph of multiple points that relates two sets of data. We'll take a look at one of these, or a few of these in just a bit. Correlation is how closely related the two sets of data are, or in a more practical sense, how close the points are to a line, how close they are together, how close they are to just forming a straight line that is easily readable. So for instance, okay, I'll make these dots a little bit darker here. If we have a series of dots that are just all over the place, they're all random, then we say that there's no correlation at all. And as you see here, this first example just has dots that are all over the place there. You can't hardly find a pattern throughout any of them. We say that that's no correlation. Weak correlation is if our dots are starting to sort of come together to look like a line. We can sort of tell which direction they're going, but they're still spread pretty far apart. So here we've got one example of weak correlation. Our line can start to correlate down. It can also start to correlate up, as I'll show you here. So both of these graphs are weak correlation because while we can tell that the lines are starting to form, the points are still pretty far apart. When we have strong correlation, we start to see the lines really come together. And as you can see here, our points are really close together. Even though they're not all on the exact same line, they're close enough together where we can say this is strong correlation here. And as before, we can have them going either up or down, different directions. We just are more concerned about how close they are together to determine if it's strong or weak correlation. So let's go ahead and graph out an example here. All right, so we're asked to graph the data here. A lot of times something like this will be presented with word problems. For instance, we've got our years here, and these could be prices of houses. And we want to go through and we want to graph this information. Well, if you try your standard graphing approach, just going up 1, 2, 3, 4, 5, that's not going to work because obviously we've got numbers like 23,000 and 89,000. So we're going to need to go by different values. Same thing for the years as well. My years are going to go down here on bottom. This is going to be our X value. That's sort of our input. And then the price is going to go over here on the Y value. That's sort of our output. We're saying, okay, in the year 1940, what's the price of a house? And we would plug in 1940 and we would get out $23,100. So I'm going to label my graph down here. And over here. Now I'm going to figure out what to go with for my scale. So notice here my year is going up by 10 each time. So I'm just going to go by tens down here. So I started down here, I said 0, 10, 20, 30, 40, 50, 60. The 0 is going to go with 1940. That's our 0 year, because that's our first year. Well, 10 years later, that's going to be 1950. 20 years after our 0 year is going to be 1960. 30 years will be 1970. And 40 years will be 1980. So we're going by 10 each time because our years go by 10 each time. We've got a little bit more flexibility with the price because obviously these aren't going up by a fixed amount, and in fact it goes down a little bit as well. So since my smallest number is 23,000, I'm going to say my smallest dash over here is going to be 20,000. I'm just going to label that 20 there. And since we're going up by, let's say, 17 here and 18 here, let's go up by 20,000 for each dash mark. So 20, 40, 60. All right, so we've got 20,000, 40,000, 60,000, 80,000, and 100,000. These are going to be different for each person. Not everybody's going to have the same thing, so everybody's graph may look a little bit different, but as long as you're graphing things correctly, they should all look similar. So for starters, we've got 1940, which is going to be our 0 year here, with $23,100. So I'm going to go here to the 0, and I'm going to go up just a little bit above 20,000 there. Not quite. I'm not going up to 40,000, just a little bit above the 20,000 there, and I'm going to mark a point. Just right there. Then I'm going to go over to 1950. I'm going to go up just a smidgen, just a tiny little bit above 40,000 there. Because we have 1950 with $40,100. Then we're going to move on to 1960. That's going to be our 20 year, and that's $58,100. That's just below the 60 there. If I go over to 30 years, that'll be 1970, and we've got 57,600. So it's actually a little bit below our last point there. And then lastly, 80 years is 89,300. So I'm going to go over here to the 40, and then I'm going to go up about halfway between the 80 and the 100. Now you can notice that this sort of starts to form a line here. I'm going to draw a little dashed blue line in here to illustrate this. So some of our points are above and some of them are below. And in the next video, we're going to take a look at what's called the line of best fit.